Hi there, thanks for joining me for our video on dimensional analysis. The goal of this video is going to be able to compare and work with quantities of different units by using a unit rate. So what that means is we might take something like 600 seconds and another quantity of 5 minutes, and we're going to use a unit rate to change seconds into minutes, so that way we can compare. We could also go backwards and turn minutes into seconds so that we can compare. So we're not really changing the value of the quantity we're working with, we're just changing the unit and scaling it appropriately using unit rates. So let's get started. So dimensional analysis is a method of using unit rates to convert a number in a given unit to a number of an equal value in a corresponding unit. So we've been using this term unit rate a lot already. A unit rate, if you think back to ratios, is when we have something out of 1 unit. So we have some quantity out of 1 unit. So if we go back here, my unit rate that compares seconds to minutes is I know that there are 60 seconds per 1 minute. So it's a unit because this is 1. We could also do another unit rate. We know that there are 60 minutes per 1 hour. So if we wanted to convert minutes to hours, that would be the unit rate we would use. So for every problem, when we use a unit rate, it's always going to be out of that 1 minute or that 1 hour. Now, we may have to reverse this, and we may have to write it as 1 minute over 60 seconds. That's okay, it's still a unit rate because it still has that 1 unit. What's going to determine how we write it is based on what our starting value is. So here's our first problem. We want to compare which is larger, 126 inches or 12 feet. So first thing we want to do is we want to think about, well, what do we know? And we know that there are 12 inches and 1 foot. That becomes our unit rate. So we know it's 12 inches per 1 foot. So what we can do to compare is we can either turn the 126 inches and turn it into feet, or we can take our 12 feet and turn it into inches. And we're actually going to do both. So over here, we're going to use our unit rate to set up our conversion problem. And first, we're going to go ahead and turn the 126 inches into feet. So I know that my starting problem is that there is 126 inches. And I've put it over 1 because all numbers have that invisible 1. So we have a nice fraction. Now notice over here, I've multiplied it by my unit rate. And in this problem, notice how the 1 foot is on top. The reason why we do that is because when we convert, we're trying to get rid of inches and turn it into feet. And when we're working with fractions, if there's the same unit on top in the numerator and 1 in the denominator, that will actually cancel them out. So that's how we're going to decide which way to write our unit rate. Is it the rate over 1 or 1 over the rate? And it just depends on what we start with. Whatever is in the numerator in our first part of the problem needs to be in the denominator in the second part. Once we have this converted, now remember when we multiply fractions, we multiply straight across. So that gives us 126 over 12. And if we go ahead and divide that, 126 divided by 12 gives us 10.5. And the only unit we have left is feet. So now if I compare, I know that this is 10.5 feet compared to 12 feet. So I know 12 feet is larger. Now let's try it again if we wanted to convert the feet backwards back to inches. So notice I started with our value. We have 12 feet and I put it over the 1. And now I've taken my unit rate and I see that I have feet on top here. So that means when I use my unit rate, I need feet in the denominator over here so that the feet cancel out and the only unit I have left is inches. And now this time when I multiply straight across, 12 times 12 is 144 over 1. So that gives us 144. And the only unit we're left with is inches. So again, if I compare 126 being compared to 144 inches, I can see that the 144 is larger, so 12 feet is still the correct answer. So what we're going to practice on the next page is first writing a unit rate and then setting up the problem so that our units that we don't want anymore cancel each other out. So let's take a look. Our first problem, we have 245 minutes to hours. So first thing I want to think about is what do I know about the relationship between minutes to hours? And like I said earlier, we know the relationship is that there is 60 minutes per 1 hour. So now, when we set up our conversion problem, like the page before, we start with what they give us. They give us 245 minutes. And we're trying to convert it to hours. So I'm going to put it over the 1, put our time sign, and now think about how do I need to write this? Am I going to put 60 minutes over 1 hour or 1 hour over 60 minutes? To help me decide, I look here. I see minutes is in the numerator, and I know that whatever is in the numerator has to be in the denominator of my next chunk. So that means the 60 minutes has to go down here so that we have 1 hour in the numerator. Now when I multiply straight across, that gives me 245 over 60. And I can see I have a minute on top and a minute on bottom, so those cancel. So I'm left with hours. And now we'll go ahead and divide. 245 divided by 60 gives us 4.08 hours. So 245 minutes is just a little bit above 4 hours. So again, the key thing we want to practice is making sure our starting numerator unit also goes in the denominator of our next part. So let's look at the next problem. We have 165 feet and we're converting it to yards. Now this unit rate might be a little harder. When you're in doubt, go ahead and look up online what the conversion is between feet to yards. Or if they give you other conversions you don't know, just look them up. In this case, the unit rate is that there are 3 feet per 1 yard. So for every yard you go, that's the equivalent of 3 feet. So now we're going to go ahead and convert it. Our starting problem is 165 feet. We'll put it over 1. And now we got to think about how am I going to write this again. So I look and I see feet is in the numerator. So that means when we go to write our unit rate over here, we need to flip it and put the 3 feet in the denominator. with the 1 yard on top. Now we can see that I have a feet on top, a feet on bottom, so I'm going to go ahead and cross them out. And I can see that that leaves us then with just yards. So now I multiply across and I get 165 over 3. And when we go ahead and use a calculator to divide that out, 165 divided by 3 gives us an even 55, and the only unit I have left is yards. So if I've gone 165 feet, that is equivalent to 55 yards. So let's go ahead and try 2 more. And I know it seems like a lot of these, but the more you practice it, the better you're going to get when you get into the assignment problems in the assignment. So let's go ahead and convert 7 hours to minutes. Well, I still know from up above that when I'm dealing with minutes and hours, my unit rate is 60 minutes per 1 hour. That hasn't changed. What has changed is now we're not starting with minutes, we're actually starting with hours. So how is that going to change our unit rate when we go to write it? Well, that means now I have hours in the numerator. So that means my 1 hour needs to go in the denominator. And the 60 minutes goes in the numerator. So now if I check, I have an hours on top I can cross out and an hours on bottom. They cancel each other out, leaving me with just minutes, which is what I wanted. And now if I multiply straight across, 7 times 60, 7 times 6 is 42. So that gives me 420. 1 times 1 is 1. So that means our final answer is 7 hours is equal to 420 minutes. So once we get this set up correctly, our unit rate, the rest of the problem is just a straightforward multiplication. So let's try one more. 20 feet to inches. So we think back, we know that there's 12 inches per 1 foot. So we start with our 20 feet times, and now I look, I'm starting with feet. So that means I want my 1 foot to be in the denominator over here, and we'll put the 12 inches on top. So now if I check, my feet will cancel out, and I am just left with inches. So we multiply straight across. 20 times 12, well, I know 2 times 12 is 24. Add in that 0, that's 240. And the only unit we're left with is inches. So our answer is 240 inches. So the key here to remember is when you set up your conversion, the units of the starting number should match the units in the denominator of your unit rate when they cancel out. So the units of the starting number, and we should add in here the numerator, should match the unit in the denominator. So hopefully that's making sense to you, because now we're going to apply this to currency exchange. If you've ever been to another country, you would know that we have to convert our US dollars, which is what this stands for in this table, US dollars, into the money amount or the currency amount of the other country. So in this table we have Canadian dollars, euros, Japanese yen, and Indian rupee. Now what they've done in this table is they've actually broken it down so that we have the US dollars per 1 unit, or they've broken it down into the units per 1 US dollar. So they've changed it, and they've already done the division for us. But I want us to look closer at what this is really saying. So if we come over here and look at the Canadian dollar, this first column says US dollars per 1 unit. that unit is whatever the currency column is. So in this case, a Canadian dollar. So what this is telling us is that 1 Canadian dollar is only worth 97 cents in US dollars. So the US dollar isn't worth quite as much as a Canadian dollar. So when we go to do our problem, if we're starting with Canadian dollars, we're going to have to use this rate because the Canadian dollar is also in the denominator. Now this problem over here, this is for if we're starting with US dollars and we want to convert it to Canadian. So here we can see a Canadian dollar is actually worth more than 1 US dollar. If you have 1 US dollar, that's worth $1.03 Canadian. So we would use this conversion rate if we're starting with US and trying to go to Canadian. So let's take a look at how this is going to work. So here we have 100 US dollars. So over here I'm going to write 100 USD. And I'm going to put my multiplying. And I know right away, since US dollars is on top here, US dollars has to go on the bottom here. And we're converting it to yen. So the yen has to go on the numerator here. That way, our numerator and our denominator cancel out. So now we have to figure out which unit rate to use. Since I see USD in the denominator here, that means I'm going to use the ratio for USD that has it in the denominator. And if I go down to Japanese yen, that tells me the unit rate is 99.30487. So that means right here, we'll put that 99.30487, and that's yen per 1 USD. So now when I want to solve, we just multiply straight across. And when we do that, we get an answer, and I'll put it down here. Let's put a 1. We get an answer of 9930.48 yen. So our 100 US dollars gets us 9,930.48 yen. So let's look at the next one. Let me erase this. Now we're converting 500 rupees to US dollars. So I'm going to start by writing what we know. I know it's 500 rupees. And now we're converting it to US dollars. So before I even look at this table and get all confused of which value to use, I'm going to set up my rate here. And I know if it's rupees on top, then rupees have to go on bottom. And I know US dollars have to go on top. That way my rupees cancel out, and I'm left with US dollars. So since US dollars is in the numerator, that means we're going to look at this column where US dollars is in the numerator. And we're going to go down to rupee, and I see that my conversion or my unit rate is 0.01594. So that's what I'm going to put here on top. 0.01594 over 1. And we're going to grab a calculator on this one, and let's multiply 500 times 0.01594. And as sad as this is, those 500 rupees are only worth $7.97 in the US. So let's try the next one. Same thing as this last one. We're converting euros. Looks like we're coming back to the United States, so we want to convert it to US dollars. So I'm not going to look over here at the table at all. I'm just going to write what I'm starting with. I'm starting with 70 euros. And my goal is to get to US dollars. So US dollars, and the euros go on the bottom. That way I can see my euros cancel out and I'm left with the US dollar again. So since USD is on top, that means we're going to stick in the same column we just used on the last problem. And we'll go to euro, and we can see that the unit rate is $1.35261 for every euro that we have. So 1.35261 for every euro. So that means the dollar is actually worth a little bit more than a euro. So that's good in our favor. So now when we multiply, we're going to go ahead and multiply 70 times 1.35261. And that gives us an answer that our 70 euros is actually worth $90 and about 68 cents in the United States. So let's try it one more time. This time we're starting with 600 US dollars. So I'm put USD. And we're converting it to Canadian. So since USD is on the top here, USD needs to be in the denominator there. And Canadian is what's going to go in the numerator, because that's what we're converting to. So in this problem, since USD is in the denominator, we're going to go back to the second column, where it tells us that our unit rate is 1.03069. 1.03069. And we'll go ahead and multiply that out. So 600 times 1.03069. And that gives us an answer of $618 and about 41 cents Canadian. So don't let this table confuse you. The process is still the same. Start by writing what we know so you can figure out, am I using the column with the 1 USD in the denominator? Or am I going to use the column with the 1 USD or the USD in the numerator? And then you multiply just like we did before. Now I know I've been talking a while, but there's one more thing we have to be able to do. We have to be able to work with multiple units at once. Because unfortunately in math, a lot of things that we do are going to involve multiple units at once. So for example, if we're driving somewhere, we tend to drive in miles per hour. Or if you're somewhere that uses the metric system, you drive in kilometers per hour. And then we could convert that into something smaller like feet per minute. Because maybe we don't have a good idea of what miles and hours is, but we know how many feet we can go in a minute. So what we're going to have to do when we start with a problem that has 2 units, that means we're going to have to actually use 2 unit rates now. We're going to have to use a unit rate to get rid of the numerator, the miles, and we're going to have to use another unit rate to get rid of that hours that's in the denominator. So let's see how to do this. Starting with a fairly simple problem, they want us to convert 60 miles per hour into feet per minute. So what that means is if I look down here, my initial problem, my start, is I'm starting with 60 miles per 1 hour. So I know the 2 things that I need to do is I need to be able to convert and get rid of miles and turn it into feet because we're trying to get feet per minute. And then we're also going to be changing hours into minutes. So I have 2 unit rates we're going to be using. There are technically 5,280 feet per 1 mile. It's okay if you don't have that perfectly memorized. I had to look it up too to make sure I was right. So that's going to be our unit rate to convert our miles into feet. And then our second unit rate that we've already used a lot, minutes per hour. We know there's 60 minutes per 1 hour. So what I'm going to do is I'm just going to focus on one thing at a time. I'm going to use my first unit rate here. And I know that I need to get miles into feet. So I'm going to ignore this 1 hour down here, and I'm going to look and say, okay, my miles is in the numerator here. So when I use my first unit rate, my miles also needs to be in the denominator here. That way they cancel each other out. And that's going to leave me with my feet. So that means when I write my unit rate, we're going to write it as 5,280 feet per 1 mile. And I've double checked, miles is on top, miles is on bottom. Now we're not actually going to do any multiplying yet because remember we also have to convert that hour into minutes. So now I look in my initial problem and I ask myself, well, where is hours? And I see that hours is down here in the denominator. So that means since it's in the denominator of this problem, when I go to my spot for unit rate number 2, my hours needs to be in the numerator here. So a denominator, a numerator cancel out, and notice I'm left with minutes in the denominator, which is what I wanted because it wants feet per minute. And if I look, feet is in the numerator, per minute, which is in the denominator. So now what we're going to do is we're going to go along the numerator and multiply. So we have 60 times 5,280. So 60 times 5,280. That gives me what looks like a crazy number of 316,800. So that's currently 316,800 feet. And now in the denominator, 1 times 1 times 60, that is 60. And then remember, a fraction bar just means division. So we're going to go ahead and divide that 316,800 and divide it by 60. So that ends up giving us a final answer of 5,280. And then remember our units, it's the numerator, so feet, per the denominator unit, minute, which is what they asked for originally. So when we're working with multiple units, it's not really harder, it's just a little bit longer. So we'll start with the initial problem, we'll write what our 2 unit rates are, and then you have to decide how am I going to write it. So for us, since miles was in the initial numerator, that's why we put it in the denominator of unit rate 1. And then since hours was in the initial denominator, that's why we put it in the numerator of unit rate number 2. So I'm only going to torture you with one more problem just to make sure you're good for the assignment and the quiz on this section. So here's our last example. We currently have that somebody can run, walk, whatever it is, 45 yards per 2 minutes. And what we want to know is how many feet is that per hour. So that means that's telling us we're going to be converting yards into feet and minutes into hours. So for our first unit rate, we need to know what's the relationship between yards and feet. And earlier we did that it is 3 feet per 1 yard. And we've been doing this one a lot. We know the relationship here is that it's 60 minutes per 1 hour. So I'm going to set it up just like I did in that last one. I'm going to write initial problem. We'll put our initial problem here. Then we'll figure out how do we need to write unit rate 1 and how do we need to write unit rate 2. So my initial problem this time is 45 yards. So 45 yards, and it tells us it's per 2 minutes. So it's 45 over 2 this time. It's not over 1. And that's because they actually gave us a different number. So now I'm going to think about this. I'm going to write my 2 unit rates, but I'm only going to focus on unit rate 1 first. Unit rate 1 is converting feet and yards. So if I look here, I have a yards in the numerator. So that means I need my yards in the denominator. So that means when I go to my unit rate, feet is going to go on top. So 3 feet per yard. And if I check, yards in the numerator, yards in the denominator, and I am left with just feet, which is what we want. Now let's focus on unit rate number 2. I currently have minutes in the denominator. So since minutes is in the denominator here, that means I need minutes in the numerator here to cancel, giving us hours in the denominator. And our conversion is 60 minutes per 1 hour. And if I check, minutes is in the denominator, minutes is in the numerator, those will cancel, leaving us with the hour in the denominator, which is what we wanted. We wanted feet per hour. So now let's grab our calculator. Let's just multiply the numerator. We go across. That tells us it's 45 times 3 times 60. So that gives us 8,100 over, in our denominator, we have 2 times 1 times 1, which is 2. So let's go ahead and divide that by 2. So that means our person is going 4,050, and I look at what's circled, what's left, feet per hour, which is what they wanted. So our person, instead of going 45 yards in 2 minutes, that means they could also go 4,050 feet per hour. Now, the one thing I really didn't focus on in this video was comparing. What you're going to have to do in the assignment and the quiz is you're going to have to convert some problem into the new units and then use that to compare with like a second person or a second amount. So you may have to do these problems twice to get 2 problems that have the same units, and then you can compare which one is larger and which one is smaller. You may also have to do it to compare how many cans of paint you need for a wall to figure out how many cans of paint you're going to need total, and to determine which measurement is actually the best. So you're going to have to go a little bit further than just converting, but as long as you know how to do the converting, then it'll be easy to do the comparing. So I know this video was longer than my normal ones, but this section, it's really important just to do it over and over again so you get the hang of it. So I hope this has helped you and will help you on your assignment and your quiz. Thanks for watching.